Hey everyone, a very warm welcome back to the channel. Today we are discussing the question number 12 from the chapter of trigonometry, in which we are being asked to simplify the given expression. Now this question can be asked in multiple ways. It can also be asked as to integrate this given function with respect to theta. It might also ask us to differentiate it. So multiple ways the question can be asked, but at the end of the day, we'll have to simplify this function first and then do whatever the question is asking us to do. So maximum time allotted for this question would be 12 minutes, and ideally you should try to do it within 6 minutes. And you can pause the video, give the question a try, then return back to have a look at the solution. So I hope you all have tried. Now let's see how to solve the question. The answer to this question, first of all, would be tan theta by 2, and concepts and formulas used are sum or difference to product and product to sum or difference transformation formulas. Like we should know sin A plus sin B is equal to how much, we should know 2 cos A cos B equal to how much, all of those formula. And cos 2 theta standard formula we should know, sin 2 theta standard formula we should know. Now let us see how to solve the question itself. So what we have actually done is we are calling the expression as E, and what we are doing as a first step is we are multiplying and dividing by cos theta, because what that does is it brings everything into sine and cos in terms of sine and cos, right? Right now we are having secant, tan, but if you multiply and divide by cos theta and cos theta, both numerator, denominator, if you multiply by cos theta, everything, gets converted into sine and cos. So that's what we have done. As the next step, you will multiply by 2 and 2. Okay, numerator and denominator, you multiply both of them by 2. So what happens is we get 4 plus 6 sine theta plus tan sine cos. So that's what we have written. But 2 cos square theta will also be generated, right? But from here, I can say that 2 cos square theta is nothing but 1 plus cos 2 theta. So that is exactly what I have replaced 2 cos square theta by in this expression, right? And in the denominator also what we have done is these terms are written as it is after multiplying by 2, but 2 cos square theta gets generated here, so that we have once again written as 1 plus cos 2 theta. Similarly, we will also get 2 sin theta cos theta here, so that once again I have written as sin 2 theta here. All right, fine. Now what we have done as the next step is very crucial. We have done some very important clubbing. The way we have clubbed the terms is very important. So let's see what we have done. First of all, 4 minus 7 into 1 will generate minus 3, right? And this 10 cos theta I have written as 7 cos theta plus 3 cos theta. That's what I will write it as. So that what now happens is I can take minus 3 common. Look, 4 minus 7 also created minus 3. And since I have generated 3 cos theta here also, so another 3. So what now happens is if I take minus 3 common, inside we'll be left with 1 minus cos theta. It's very simple to understand that we can take it common like this. Moreover, we are also going to take this 7 and 7 into cos 2 theta that will be generated from here. 7 common from that, so that we will get cos theta minus cos 2 theta inside of the 7. Further, what we are going to do is from these two expressions, we are going to take 2 sin theta cos 2 sin theta common. So inside we'll be left with 3 plus 5 cos theta, right? And in the denominator, what we have done is we have once again done the same type of clubbing. So the way we have done clubbing is 6 plus 5 into 1 will generate 6 plus 5, which is 11. So since 11 is being generated, that's why I will break this term as 11 cos theta plus 5 cos theta. So doing that allows us to take 11 common in 1 and cos theta, right? From this expression, and 6 plus 5 was also 11. From that expression, I have taken 11 as common. Then this 5 cos theta and 5 into cos 2 theta here, right? From these two terms, we are going to take 5 common. So inside we'll be left with cos theta plus cos 2 theta, right? Then we are also taking, now comes a very important step, 4 sin theta, we will write it as 7 sin theta minus 3 sin theta. Why are we doing that? Because we already have a 7 sin 2 theta here, right? So what I have simply done is I have taken to take 7 common, I have forcefully generated a 7 here so that I can take 7 common, and we are left with sin 2 theta plus sin theta inside. And this minus 3 sin theta I have written as it is here. Okay, so that all the terms are covered in this manner. Now what we are doing in the numerator is we are simply applying the formulas. Okay, the way we are doing it is sine theta I have written as 2 sine theta by 2 cos theta by 2. That's what I have written sine theta as. Then in this cos a minus cos b formula I have applied 2 sine a plus b by 2 sine b minus a by 2. That I have applied here. Now what have we done here? In 1 minus cos theta, I have written it as 2 sine square theta by 2. These are very simple, submultiple angle formulas, which are very standard. So those are the ones that we are using. What is 1 plus cos theta in the denominator now? Obviously, that is 2 cos square theta by 2. Cos A plus cos B formula I have applied here and written this expression like this. All right. Then sin A plus sin B formula I have applied here and written it like this. And sin theta, once again, I have applied submultiple angle formulas to write it as 2 sin theta by 2 cos theta by 2. Now, what we are doing is we are taking 2 sin theta by 2 common from the numerator and 2 cos theta by 2 we are taking common from the denominator. Okay, so what are we left with in the numerator and denominator? We are left with these two expressions. All right, it's very easy to see. Okay, nothing difficult. We have just taken common. So obviously the 2 and 2 get cancelled and sine upon cos gives us tan theta by 2. Now look what's happening. Now is a very important step. We are opening this up. So 2 3s are 6 cos theta by 2. That is here. Now what happens is this 2 into cos into 5 into this cos. So 5 I am keeping aside. This 5 is here. And 2 cos A cos B formula I am applying here. Cos of A plus B plus cos of A minus B. So that's exactly what we have applied in the numerator. Remaining terms we have written as it is. No change there. Okay. Now clearly you can see 6 cos theta by 2 and 5 into cos theta by 2. When they are added, they would obviously give us 11 cos theta by 2. And 5 will be multiplied by cos 3 theta by 2. So that term is also present in the denominator. Remaining terms are anyway identical. So you understand, numerator and denominator has now become identical after simplifying. So this gets cancelled out. So we are only left with the term, with the expression tan theta by 2, which is our final answer. So I think this was a little bit tricky. This question was on a little bit trickier side because thinking of these steps in this, sequence and in this manner, in this chronological order would have been something that students might struggle with. And this is what probably makes it a little bit difficult, to solve this particular question. But anyway, when I explained and now that you have the explanation at hand, I hope you are able to follow through and were able to understand on how to tackle these kinds of problems. So make sure you like the video, comment down below what you like the most, subscribe to the channel, hit the bell icon to never miss an update, and I'll see you all in the next one.